We are solving a question from the atoms chapter. This is from 21st January shift 1 JEE Mains 2026. It's a question on Rutherford alpha particle scattering experiment. I will summarize the question. You can pause and read it. They are launching an alpha particle with a kinetic energy of 7.7 mega electron volt, and they are asking what is the closest distance of approach from the nucleus in the alpha particle scattering experiment. As we already know, there is a gold nucleus in an alpha particle scattering experiment, and in this experiment the alpha particle, which is doubly ionized helium atom, is actually launched towards this gold nucleus, say at from some distance of infinity with a kinetic energy k. So as it comes closer, it's repelled by the gold nucleus as it has a positive charge, and alpha particle is also positively charged. Finally, when it reaches the closest distance, say d, its entire kinetic energy becomes 0. So if I apply work energy theorem, work done by electrostatic force is equal to change in kinetic energy, because that's the only force. Work done by electrostatic force is negative of the change in potential energy, and that is equal to change in kinetic energy. Final potential energy is, say, U final, minus initial potential energy is U initial. Initial kinetic energy is 0, initial kinetic energy is k, and final kinetic energy is 0. So I've substituted final kinetic energy 0, initial kinetic energy is k. So minus U final is E into ZE divided by 4 pi epsilon naught R, or D in this case. I am using k q1 q2 divided by R as the potential energy between two charges. Initial potential energy is obviously 0 because the charges are separated to infinity, and here you have a minus k. So you get k is equal to ZE square divided by 4 pi epsilon naught d. There is a slight mistake over here. I have taken the charge of alpha particle as E, but actually it is 2E because it's doubly ionized. So we should be having 2ZE square over here. That is a mistake on my end. So it is 2E. The charge of alpha particle is 2E. So now if you calculate the D comes out to be ZE square divided by 2 pi epsilon naught kinetic energy. Remember, the kinetic energy is in mega electron volt. To get answer in SI unit, you should convert that also into joules. So what is the value of Z? Z is 79. E square will be 1.6 into 10 power minus 19 whole square into 1 by 4 pi epsilon naught is 9 into 10 power 9. Therefore, 1 by 2 pi epsilon naught will be 18 into 10 power 9 divided by kinetic energy 7.7 mega electron volt. Mega is 10 power 6. 1 electron volt is 1.6 into 10 power minus 19 joule. If you go through with the calculation, this comes out to be 2.95 into 10 to the power of minus 14 meter. This seems to be option